questions about locus, and now we are talking about a parabola. And this is open upward is because the coefficient of x squared is positive. This is not very good drawing, should be symmetric, but we just need to roughly draw the situation and understand what it's asking first before we really start our calculation. And then those are straight line y equal 19, so we have our horizontal straight line y equal to 19. And then they say that we have to prove L and inverted L, that means the curve and our horizontal line, we have two intercept points, because it's also possible that they do not intercept each other. So we are considering the intercept point and then the solution. We are asking how many solutions here. So that's why we have to consider the intercept point. Part A for the intercept point. We are talking about its line on the parabola fulfill this requirement. And at the same time, its line on fulfill the second requirement. So that's why it's substitution. It's a quadratic, so we have to put everything to one side to use the standard form. And then we identify A, B, C easily. After that, we have to prove there are two solutions, real solution here. So to do so, we are going to consider delta of this equation. Delta is equal to something b squared minus 4ac. So this is 4 times k squared minus 2k plus 1. And then we have plus 4 times negative 2 multiplied what inside, positive 6k. And then we have positive 22. That's why we have k squared and then plus 4k and then plus 23. It's not strong enough to prove that it's always larger than 0. So we have to change it to vertex form. It helps us to distinguish the minimum or maximum. So k squared plus 4k, 4k that means 2 times k times something. We have to guess what's that. That is 2. So what we need is we need 2 squared, but I can't create from nothing. So I should subtract 2 squared immediately to avoid any value change. And then after that we still have plus 23, so we write down plus 23 here. The first three term, k squared plus 2 bracket k bracket 2 plus 2 squared will become a complete square, k plus 2 squared. And then after that we combine these two terms, 23 minus 4, we get positive 19. Once we write in this form, this part must be positive or 0. Add some positive. So that's why we have enough evidence to say that therefore delta larger than 0. This is larger than 0, no matter what is the value of k. Therefore, we prove there are two solutions. That means two intercept points. That's how you prove part A. Repeat again. We are considering how many solutions for the intercept point. That's why we handle the simultaneous equation. And then it's form a quadratic equation. And then because we want to know this quadratic equation is there one real root or no real root or two different real roots, that's why we consider a quick test method, which is the denominator determinant. And then that's something inside square root of quadratic formula b squared minus 4ac. And then we find that we can express in terms of k, but this expression is not strong enough to prove it's always positive. That's why we have to change the format by computing square. This kind of format is help us to identify all the variable inside the square. So something square, positive or 0, plus some values, then that whole thing must become positive. That's why this kind of format is strong enough to say that delta is always 0, no matter what is the value of k. And then therefore we have enough evidence to claim that there are two different intercept points. And then in part B, they say that A and B are the x-coordinate of A and B respectively, because they intercept at 2 points. So let's say if I let this point be A, this point is B, and then this coordinate will be A something at 19, because the red line is horizontal line. So the B coordinate is B19. And then we have to prove A minus B is equal to this. That means we are asking what is the differences, distance here. Before that, A is the intercept point. That means A is a solution or root of this equation. And at the same time, the same B is also the root of this equation. So if we concern about not A but B, but we concern the sum of them or the differences between them, then we are considering alpha plus beta, which is equal to negative B over A, the sum of roots. Or we also know that the product of root is C over A. Thus we are going to calculate. Remember, you are not going to solve what x is equal to something or something. We are not going to do so. But in short, we just try to get their sum and their product to build up other components. So here, A plus B, sum of root is negative B over A. That means the coefficient of x divided by the coefficient of x squared. Then we get k minus 1. At the same time, alpha plus alpha beta, that means AB here. The product of roots is the constant divided by the coefficient of x squared. We can't simplify, we just leave it like this. After that, we are going to build up what we want. What we want is A minus B squared. If we expand it, it is equal to A squared minus 2AB and then plus B squared. It's a very common exercise in your textbook that A squared plus B squared, we can add something between them so that it's become identity. But again, I can't just simply create from nothing, so I have to subtract it immediately. That's why we have A plus B squared and then minus 4AB. We have all the components we need. We have A plus B, we also have AB, so I just replace it. K squared minus 2k plus 1, and then everything times negative 2, so positive 6k, positive 22. And the question is so good that they provide us the result so that we can check. It seems that there is no mistake here. Part C is about the distance between A and B is that less than 4. So just like what we have mentioned, A minus B, that implies the distance. So why they need you to write down A minus B bracket square is because this is related to our distance. Again, we need to compare with 4, so we are asking about the minimum. A minus B squared is equal to k squared plus 4k plus 23. We just perform computing square once again, so it's exactly the same calculation just now anyway. So plus 19. That's why the minimum A minus B squared is equal to 19 is because square term can't be negative. So the minimum A minus B is equal to square root 19. and then this is larger than 4. So even the minimum distance is larger than 4. That's why it can't be less than 4. Therefore, not possible. Once again, our vertex form is really good to calculate the minimum or maximum for a quadratic expression. In this calculation, we change it to vertex form. That's why the minimum for this whole thing is 19. And then compare with the distance, that means without square, we take square root, and it should be 4 point something, between 4 and 5. So that's why even the minimum is larger than 4. So that's why it can't be less than 4.